Hey everybody, it's Phil, and today I want to talk about Guess the Number. I want to talk about how we're going to play the game, or more specifically, the algorithm or the algorithms that we could use to play this game. First, I want to talk about linear search. In linear search, we're going to do just as it says and go in a line. So we're going to start over on the left-hand side with 0 and check to see if that's a secret number, and if it isn't, we move over to 1. Check again. Nope, that's not it. 2, that's not it either. And as you can see, this could go on and on and on over and over again. So that is not probably a very efficient search. How about binary search? In the directions for how to implement the game, there was a link to a Wikipedia article on the binary search. The binary search is a very, very powerful way to find a number in a list. So let's say we start with this list again. We have the numbers 0 through 9. And this time we're going to take the low point and the high point and find the center. So what we can do is add those two numbers together and then divide by 2. So that's how you find the average. So the midpoint is the average of the numbers. So in this case we end up with 5. And if we check to see if 5 is the number, and if it isn't, then we're going to see if it's lower than 5 or greater than 5. And then in this case, we're looking for a number that's less than 5. So we can get rid of half that list. So now we're only searching in a range of 0 through 4. So once again, we have to find the middle. So in this case, the middle is 2. Then we check the left and check the right and get rid of the part that we don't need. So now we're down to only 2 numbers. So then we check to see if it's 3. And then we finally find our number, and it's 4. So you can see those steps might not seem like the most logical way at first, but hopefully I can demonstrate for you how this is a very, very powerful way to find a number in a list or to win this game. So let's talk about the algorithm. I'm just going to explain it in pseudocode, which is just plain language explaining the steps. So first, we need to find the midpoint. So to find that midpoint, we take the high and the low of our range and divide by 2. The next step we do is check to see if the mid number is equal to the secret number. If it's not, if the mid number is less than the secret number, then we make the low point equal our midpoint. So what was the midpoint, or the number we just checked, becomes the low end of our range. And then if the midpoint is greater than our secret number, what we have to do is make the high become our midpoint. And then the next step is we repeat the same steps over and over again until we find the secret number. So let's take a look at this in CodeSkulptor. So I wrote the binary search algorithm here using the event-driven program and using a canvas. So first thing I want to talk about is this log base 2 event. So if you implement it in Guess the Number, the log base 2, you know we had to take in the range, so that could be this int num, and this 2 over here is base 2, and then we used math.ceiling to take it to the next larger integer. So if you do this for 100, your answer is 6 point something, so we want to make it go up to 7 to give you 7 guesses. Alright, now let's look at the actual algorithm for the binary search. So like I said, what we do is we find the midpoint. So when we start our game here, we find our initial midpoint by taking our upper and lower bounds and divide that by 2. And then what we're going to do is we're going to check to see if that number is higher or lower, and then I have these buttons, a high button and a low button, and you will push the higher button if the number is higher, and you push the lower button if it's lower. So let's see what we do with the algorithm here. So if it's higher, that means that the number is higher than our current midpoint. So our current midpoint is called guess, or our current guess point, so we make lower equal to guess. And then we do our formula again, where we take the upper and lower and divide by 2. And then number of guesses plus 1. And then the same thing for the lower here. So if the number is lower, we're going to do the reverse and make our upper equal that mid guess. Then upper plus lower divided by 2. Alright, so let's play this game and see how it works. So let's enter a positive integer. Let's start with 100. So it says think of a number between 0 and 100, and the computer can guess your number in 7 or less. So let's say our number is 73. So is your number 50? No, it's higher. Is your number 75? It's lower. It's higher than 62. It's higher than 68. Higher than 71. There it is, 73. So it took 6 guesses. Correct. Alright, so that was kind of worked as expected. Let's do it one more time, and let's look at down here on the bottom where it says search range is currently 0 to 100. So let's do that 73 again. So now it's higher than 50. So now you can see our search range is currently 50 to 100, so it's half the size. And now our number is lower, it's going to have that size again. So now we know our number has to be between 50 and 75. And then we know it's higher. And you can see as our search range gets smaller and smaller. And there we go. It's correct. So let's look at the power of this search algorithm though. So we know that if we make our range 1,000, that we get 10 choices. So let's make this 1,000. Let's make it 10,000. So our number is 10 times as big when we go from 1,000 to 10,000, but we only need 4 more choices to guess our number. That's pretty impressive. How about if we do, say, 1,000,000 choices? 20. As you can see, that's pretty impressive. That with only 20 choices, you can figure out what someone's secret number is between 0 and 1,000,000. So hopefully, you can utilize this technique both as a way to think of a really powerful way to search, but also a way to make playing the game, guess the number, a lot more effective and a lot more efficient. Thanks. See you next time.